Okay, so gonna go ahead and get started. Yeah, there's some stuff on the screen that I was doing before I hit live. Disregard it, just like emails or whatever. Okay, so again, this is just repeat notes over the stuff that I covered yesterday, since the notes just kind of fit well together in one. So, yeah. Friendly reminder that tomorrow, April 8th, the school district, we had a lot of donations of school supplies, so we're giving away some free school supplies to those who need it. There's a photo of that information that got put on Google Classroom as well as on Remind. So if you or anyone that you know is in need of school supplies tomorrow, they go to one of the 7 campus meal locations. The high school is one of those, but if the elementary schools are closer to you or whatever, um, you can pick up some school supplies. I'm not exactly sure what's available, but it's worth it if you're in need. Okay, so spread the word on that. So today we're going to be covering the same notes that we did yesterday. We will look at transformation statements of two functions, their attributes using Desmos.com, solving them, and how to find the inverse. All right. Okay, so transformation statements on these guys. Let's see. Starting off with this negative out front. The negative tells us that the graph has been reflected. And specifically, in this case, over the x-axis. The 2 on this problem and it tells us that we have a vertical stretch because the value is greater than 2 by 2. The +4 inside, which is our C value. This is really like thinking a -4. So this is going to the left 4. And lastly is -1 on the outside. So it's like we're going down 1. Okay. And second problem. The 2 inside the cube root here, so it's inside. So inside stuff is our left, right, our horizontal changes. So this is a horizontal. Remember, inside stuff is always opposite of what it seems like it should be, because it's near x, and your x always lie to you. So this is a horizontal, this is a 1/2, and since that value is less than 1, this is a compression. This is a horizontal compression by 1/2. This one is left 1 and, oh shoot. Sorry, one moment. See, we're going left 1 and down 4. Okay, so those are different transformation statement examples on those. Alright, so determine domain range XY intercepts using Desmos.com. And the reason you use the Desmos is so we can graph it. Desmos is free. It's really well renowned. So that's why I'm recommending that you guys use this one. So I'm going to show a little bit on my end what that looks like. Okay, so either on a computer or if you can do it on the web browser or if you want to get the phone, that's cool. The phone app as well, that works as well. So Desmos, DESMOS.com, start graphing. So it opens up this. So I'm going to type in this first function just like I see it. So f of x equals -2 x plus 1. Now to get the exponent, there should be like down at the keyboard at the bottom, there's something that looks like a to the b, this guy right here. I'm going to click on that and he lets me type in any exponent. Okay. And then what was it? -4? Yeah. Alright, so there's our function. Gonna turn on projector mode here. Should I reverse contrast? Ew, no. Okay. Now I want to figure out the domain, the range, the x and y intercepts. Okay, so starting with domain. So domain, that is our x values. You know, we're going all the way from the left to the right. Hold on. The left to the right. Sorry, playing with the webcam here. So this function looks like, yeah, it does extend all the way to the left. Like if I kept zooming out, like it does keep moving over there. The left all the way to the right. So we call that all real numbers. Okay, so I'm going to keep that in mind because I can't really switch back and forth. So our domain for the first function is all real numbers, that fancy R thing. Our range is about our y values, so bottom to top. So all real numbers again. Okay, so let's see. Our x-intercept is at -2.26. I'm going to write that down because again I can't switch back and forth. -2.260. And our y-intercept, do I have the right function here? I do not. Un momento. I need to change this to a 4 and that to a 1. My bad. Okay. The only thing that changes is going to change our intercepts. So instead, our x-intercept is at -4.7940. And our y-intercept, I can't see my y-intercept immediately, so I'm going to scroll, either click and drag with my mouse, or just swipe up with my phone all the way until I see that red line. Looks like it starts to cross. I can touch. There it is. And so my y-intercept is at 0, -129. Reason is just that cubes get so big so quickly that they move a lot faster. Alright, to go back to like the main pretty zoom, there's a little house over here on the left hand side. I'm gonna click on that. Brings me back to like the normal zoom. So I'm gonna go back to the notes now and write this stuff down. Alright, so for domain we said it was all real numbers. Range 2. Our x-intercept we found to be -4.7940. And our y-intercept was 0, -129. Okay, now do the same thing with the other one. Alright, so I'm going to close out of this. Boop. So cube root 2x plus 1 minus 4. Alright, so how to type in a cube root on here. So if you're on a desktop, you do want to like click on the bottom so where this kind of pops up. If you're on your phone, this should already be down at the bottom. And then we're going to go to functions, miscellaneous. And then right here is the nth root. So we get to pick what little number is going to be sitting on the shelf. So click on that one. Type in 3. Go over 2x plus 1. Get outside of the house, minus 4. And if you want to, you can turn off the red one by just clicking on, or the first one by just clicking on its color. Okay, so here it is. And just like the cubic, it has a domain of all real numbers going all the way left, all the way right, and a range of all real numbers going all the way up, all the way down. So let's see, our x-intercepts here, or no, that's our y-intercept, my bad. Our y-intercept is at 0, -2.74. And our x-intercept I need to scroll for a bit to find. Boop. There it is at 31, 0. I'm sorry, headphone users, that was probably loud. Alright, back over the notes. Jot that down. So it was all real numbers again for both the domain and the range. Our x-intercept we found at 31, 0, and our y-intercept at 0, -2.74. Cool. Alright, moving on. What did that button do? What? This series lets me split screen. like while using Doceres? Oh my goodness. Game changer. Sorry, that made me excited. Oh, okay. Nice. That's gonna be helpful for this next part. Alright, so let me make that smaller. Sweet. Ah! I didn't know that was a thing. Oop. Well then. Technical difficulties. I've never done this part before. Okay, so now we're gonna do the solving part. Click on that, and then I went like that, and it made it its own window. And went like boom, and like boom, and like boom. Sorry, I have to deal with my antics. Okay, so we're going to solve these two equations. So we have negative 2 times x plus 4 quantity cubed minus 1 equals a negative 5, or equals 5, my apologies. So it said note these answers will most likely be decimals, so we're going to round to 2 places. Okay, so in this problem, first thing I need to do is get everything away from the thing that is being cubed. So I got to get rid of all the junk on the outside. So I'm going to start by adding over the 1. I'm going to write a bit bigger if I'm trying it this way. The reason I have it split screen like this is nice because I'm going to be doing some things on like the calculator, so it'll be helpful to have Desmos open. But I can try to make it a bit smaller so that's bigger. Yeah, okay. Start by adding 1 on both sides. Negative 2x plus 4 quantity cubed equals 6. Then I'm going to divide by the negative 2. Yes, it's negative. That doesn't mean we should add it over. It is still a coefficient. It's still multiplying. So then we end up with x plus 4 quantity cubed equals a negative 3. Now to get rid of a cube, we cube root. They share that same word. And this is the part where I'm going to use the calculator, and I'm going to have Desmos use that for me. Okay, so I'm back over here on Desmos. So I'm going to pull up that same cube root symbol. And now I'm going to type in negative 3 into the house. The nice thing about Desmos is if you don't put a variable in it, it treats it like the calculator screen on our Inspires. So it will just evaluate stuff there. So let's see, we got, remember, if I'm telling you to round to 2 places, you always want to go much further, and on the in-between steps, you don't round to the very end. Prevents rounding errors. 4, 4, 2, 2. All right, and our last step here is to subtract 4. Okay. So I'm going to use this calculator here. I'm going to type in the previous line. I know there's a way to like bring it down, like answer like on the Inspires. I just don't remember at the moment. It just makes it negative 5. Silly me. Alright, so rounding that to 2 places, we got negative 5.44. Boom. Alright, second problem. Okay, got to get rid of all the junk on the outside of the house. So I'm going to start by adding over the 4. And get the cube root of 2x plus 1 is equal to 9. Well, now I have a cube root that I need to get rid of, so I'm going to cube both sides. Cube, cube, okay. Get 2x plus 1 equals whatever 9 cubed is. I don't remember what that is. We don't have our lovely power posters here. So I'm going to go 9 cubed, 729. Holy cow. Okay. Let's see, then I need to divide that by 2. Get 364.5. And then I'm going to subtract 1. So we get x is equal to 363.5. So answer for that one. Okay. They're probably not going to be pretty answers on the assignment. Just so you know, be prepared for that. Just round to 2 decimal places. It's all good. Alright, moving on. Ooh, okay. Still learning that part. I didn't know that I could go split screen on Desmos, so exciting. Okay, inverses. I term the inverse function. So these are the functions that are like mirror over the line y equals x, that they undo each other, things like that. Alright, so first thing you do is you switch x and y, and then you solve for y. So fx is the same thing as y. So this is going to be x is equal to -2 y plus 4 quantity cubed minus 1, and then I'm going to solve that for y. So a lot of the same steps that we did on the problem just above this on this sheet of paper, we're going to do this one. First, I'm going to start by adding the 1, then I'm going to divide by -2, then I'm going to cube root, then I'm going to subtract 4. Same deal. Okay, so add 1, x plus 1 equals a -2, y plus 4 quantity cubed. Divide by -2, divide by -2. Now my recommendation when writing down the next step here is actually, instead of writing it like the x plus 1 divided by a -2, which is kind of like a really weird looking fraction, I'm actually going to change that -2, I'm sorry, into a -1/2 pulled out front. That'll help with coming up with the transformation statements later, which is something you have to do on the assignment. Y plus 4 quantity cubed. Then to get rid of the cube, I'm going to cube root both sides. I'm going to cube root all of the left-hand side. Okay, everything goes underneath the house. Okay. So I'm left with the cube root, -1/2, x plus 1 is equal to y plus 4. And then I'll subtract over the 4 to the other side. Oops. -4 equals y. There we go. Boom. So that's one way of doing it. That's the algebraic way of doing things. So we showed you this way, and then we did like a verbal way as well, and I just told you to pick whichever way that you liked better. So in this one, it's really doing it verbally. It's really opposite operations in the opposite order. So you're thinking about what's happening to x, and then thinking about the opposite. So the first thing that's happening to x in this problem was we add 1. The next thing that happened was it was multiply by 2. Then it was cube rooted. And lastly, it was subtract 4. So now I'm going to figure out the opposite of each of these statements. So subtract 1, divide by 2, cube, and add 4. Opposite operations in the opposite order. So this is now my step 1, my step 2, 3, and 4, counting up. So if I want to go write my inverse function from here, f-1 of x, let's see, so step 1 is add 4. Step 2 was cube, so all of it's being cubed. Step 3 is divide by 2. So instead of writing divide by 2, I'm going to write a 1/2 because it's the same thing. And then subtract 1. Boom. Either method you prefer, I don't care. It's there for you. So it's one way to do it algebraically because it's extremely similar to solving like we did on the previous line, or verbally if You don't want to do it algebraically. All right, I'll be available for about the next hour or so on Google Hangouts if you have any questions for me. Okay, thank you so much. Bye.